Hello, this is Dr. Henry, and we are continuing our notes on stoichiometry. So what we're going to be looking at today is what's called a gram-to-gram problem or mass-to-mass stoichiometry. And we have a map for solving gram-to-gram problems. So we previously did some mole-to-mole problems, and that is the middle part. And let me get my pen. I got my pen. That is the middle part right here. So we've done mole-to-mole problems. Now what we're going to add to that in gram-to-gram problems is we're going to add going from grams given to moles given. All right? And we've done gram to mole conversions before. All right? We just did going from moles given to moles wanted. And now what we're going to add to that then is going from moles wanted to grams wanted. All right? And sorry, that's not a very pretty wanted. So basically, we're putting together three things that we have done separately before, but now we're putting them together in one problem. And this is basically the template for the fence post that we're going to use for this. You're going to be given X amount of grams given. It's going to be some reactant or product in a balanced chemical equation. And then you're going to convert that to moles of given. Then you're going to convert that to moles of wanted. And then you're going to convert that to moles of given. And I just noticed that this should probably be, these units here will be moles wanted, and this units here will be moles given. So maybe add that to that when you're copying this down. All right. So when you do a gram-to-gram problem, when you do a mole-to-mole problem, any stoichiometry problem, you have to make sure the equation is balanced. All right. So the equations we're looking at today are already going to be balanced, but you need to check it out, because if you don't have the correct balanced equation, then the answers are going to be wrong. So here's our problem. If we start with 40 grams of oxygen, how many grams of iron 3 oxide can we make? So the first thing we need to do is we need to find out what we're starting with and what we're ending with. So what are we given? So if we read the problem, we're starting with 40 grams of oxygen and we want grams of iron oxide. So we're starting in this box and we want to end up in that box. All right? So how many calculations is that going to take? Well, it's to go from here to here, it's going to take 1, 2, 3 calculations. And we could do this separately. We could convert 40 grams of oxygen to moles of oxygen in one problem, and then use moles of oxygen to convert it to moles of iron 3 oxide, and then do another problem to convert moles of iron 3 oxide to grams of iron 3 oxide. But instead of doing that, what we're going to do is we're going to do this in a triple fence post. It's going to be exciting. All right. So we know that we're starting with 40 grams of oxygen. And the first thing that we need to do is we need to convert that to moles of oxygen. All right. So we can think of this, it says grams of A, which we said is our wanted, but A is really oxygen, so we need to go to moles of oxygen in our first. So we make our first fence post, right? And this is just a grams to moles problem that we've done before. So in the upper left, we put 40 grams of oxygen. So if we have grams of oxygen in the upper left, what goes here? Well, remember, whatever you start with always goes here. So we have grams of oxygen in the bottom right, and we want moles of oxygen, so that goes in the top right. And remember, when we're going between grams and moles, what do we always put in front of moles? Well, we put a 1 there because 1 mole of oxygen, what's the mass of 1 mole of oxygen? That's the molar mass. So the molar mass of oxygen is 32 because we have 2 oxygens, and we look on the periodic table, every oxygen is 16, so that is 32 grams. So that's our first calculation. This converts grams of oxygen to moles of oxygen. All right, so let's go to the next step. All right, so here's what we've started with. So we have converted